All right, this is Mr. Wyrick. I'm going to go over these notes pretty quick with you here. So this is distributions as functions. We're talking about using a distribution, something like the graph we'd have over there is like a histogram, and using that line that's over on the top of it and saying we're going to convert this to a graph in function notation. So you're going to get this kind of like you're in the classroom today. So first off, what is a function? Well, if it's going to be a function, and this is slide number 2 of the notes that have been shared with you. If it is a function, we should see y equals, or f of x equals, or one output for each input. The fact that you can graph it, it should pass the vertical line test. It has a domain and range, or inputs and outputs. And there are many different types of functions. We had linear and quadratic last year in Algebra 1, so you've probably seen that there are a couple more. We talked about absolute value, and then there would be third degree equations, fourth degree equations, all the rest of those, okay? So the one thing I needed to make sure to add into your notes is this line right here, the one output for each input. Make sure you put that there in your notes. Okay, that's going to help us determine that it is a function, not just a relation, not just a random graph. So when we read this table, we have a lot of information over here about number of hours slept on a school night, and then frequency over here, and these kind of go up and then come back down. So how could we create a graph from this? Attempt to make a graph with your group. You don't necessarily have to do that. This would be like a histogram, bar graph kind of thing, or you could make a dot plot. A dot plot would be maybe useful. You're going to see some dot plots on your assignment for today. So if we made that dot plot and then removed the dots that were underneath it, you would see this. This is just the top dot of everything that would be on that dot plot. Okay, and what would be the inputs and outputs? Well, the inputs would be over here, hours of sleep on a school night. The outputs would be the frequency with which that was selected. So we can see it's kind of reversed from how you would say this out loud, but you're still dealing with, that hours of sleep on a school night there, that's our input because that's the independent variable. That's what somebody chose. And then the number of people that chose it are dependent on how many hours did they sleep? So we can tell the relationship between them, even though it seems backward from how we would say it. We would probably say one person said they got 4 hours of sleep. This looks kind of like a quadratic equation. Again, it kind of backs up what we were looking at there on the table. It goes up, it comes back down. It appears to kind of curve. Okay, so how would we interpret f of 5 equals 6, f of 9 equals 5? If you don't remember function notation, add this into your notes, this back here. If we have function notation, we have something like this. F of x equals 3x minus 2. So if we're going to find out what our input is, we take our input and we're going to multiply it by 3 and then subtract 2. So f of 4 would be our input. We input 4, 3 times 4 is 12. We subtract 2, we get 10. We put in 4, we get out 10. So that's our function notation. So then as we look up here, f of 5 equals 6 means we put in 5, we get out 6. So if we put in 5, that means we choose the option of 5 hours of sleep on a school night, and the output would be 6. 6 people chose that particular thing as how many they got on the survey. So f of 5 equals 6, that would mean the number of people that selected 5 hours of sleep a night was 6. Or the number of people that reported they got 5 hours of sleep a night would be 6. The f of 9 equals 5 is a similar kind of thing. If we look over here at 9 and we go up, we see it's across at 5. So the number of people that said they got 9 hours of sleep on a school night was 5. And then what is the value of f of 7? If we look at 7, we go up, it's all the way up there at the top at 10, which would be 10 people that said they get 7 hours of sleep on a school night. What is the domain of this situation? Again, it's an example I had on the back board, so we're going to walk back again. When we're dealing with domain, you've probably seen examples like these top two, where it's continuous kind of domain, either in inequality notation or set notation. But we need this discrete notation down here at the bottom because this is a survey and the only options are whole number hours. There's nothing where you could just type in, I got 5.5 hours of sleep. You're getting sorted into a specific number of hours. So you'd have to choose if you think it was closer to 5 or 6. So we need these numbers with the commas between them, okay? That's a discrete domain. Make sure you add that part to your notes. We have a discrete domain here. We have a discrete range. The domain is going to be the number of hours slept on a school night. The range is going to be the frequency with which people selected them. And again, it's going to be numbers with commas on there. Okay, moving on in the notes, just a couple more things real quick. Oh, no, that's it. You have an assignment in Schoology. It is a PDF. There's 9 pages to it. Don't freak out. You're not going to do the whole thing. You just need to do the 1.5a. So let me try to show it to you here. You probably won't be able to read the specific stuff, but if we go from the top, and again, there's a lot of space for graphs. There's not that many questions. It has some questions like we saw on the notes, the examples today. It talks about a different survey. It says, does this make sense with how we're answering? Then it has a dot plot, and it asks you to make the dot plot into a table. So it's got this huge table here. And then it says, let f be a function and graph that same thing as a function. So instead of filling in the whole dot plot, you would basically just fill in only the top dot. And then it'll ask you about the different stuff and ask you to rearrange it a little bit, kind of put it into some ranges of times instead, and then make a graph of that based on what you see, okay? When you get to this blank page, that's where you stop for today. We'll go over that tomorrow, of course, and then we'll pick up on the rest of the notes and finish out 1.5b. We'll hand that all in at the same time. If you have any questions, make sure to save them, write them down, whatever you need to do to remember them, and ask me when I come back tomorrow.